Have you started using Purview and are looking to expand beyond scanning assets? Are there data sources you want to catalog but don't have a connector for? Do you want to create data lineage yourself? If you answered yes to any of these questions, then you're on the right video. Hi, I'm Will Johnson, a cloud solution architect at Microsoft, and I'll be giving you a guided tour of the Azure Purview REST API. I'd like to note that currently the Purview REST API is still in public preview, and so this may be changing at the time of general availability, but by the time we finish this video, you should feel very comfortable with the models and type systems that are powering Azure Purview's data catalog, creating entities and assets and their types programmatically, developing custom lineage programmatically, assigning glossary terms through the API, and then also developing your own custom schemas for your assets in Purview. In this presentation, we will start with the type system and go through an example that's probably very relevant to most people, an Azure SQL table. That'll give us a grounding inside of the Azure Purview type system. Next, we're going to see then creating our own custom types and entities, as well as then creating custom lineage and relationships, like, for example, assigning a glossary term to a particular asset. And then throughout the entire presentation, we'll be going and referencing the individual API endpoints that you can use to actually implement some of this yourself. Throughout the presentation, you'll be seeing me referencing the Apache Atlas package. This is currently an open source solution that wraps the Azure Purview and Apache Atlas APIs that are powering Purview in a very nice Pythonic way. Eventually there will be an official SDK, but if you want to get started right now, you can either work with the Purview Swagger API to develop your .NET or your Go or your Java SDKs yourselves, or you can, of course, use things like AutoRest to generate those SDKs for yourself as well. This particular package has been led through a few members of the Microsoft community and are developed to make it easier for our customers to jump in right away. So it has handy features, and most importantly, it looks like pseudocode. So you should be able to understand the concepts very, very easily as we go through this presentation. Let's start with the type system. In order to work with Azure Purview's type system, we need to understand a few core concepts. If you're familiar with a programming language that is object-oriented, this will all come with you very, very quickly. If you're not familiar with them, then hang on, let's get through this, and I think you'll start seeing how it all pieces together. For the most part, the number one types that you are going to use are Azure built-in ones, like an Azure SQL table, an Azure Data Lake Store, and eventually you may want to create custom ones. So in order to create those custom ones, we need to understand how did something like an Azure SQL table come into existence. Well, an Azure SQL table is going to have attributes, which we'll see in a little bit here, but it actually inherits some of those attributes from a dataset entity type. And this dataset entity type is the concept that you will use probably 9 times out of 10. It allows you to create tables, columns. It is the primary type that is being used that virtually all other Azure built-in types are using under the hood. And we can see this concept of inheritance, right? An Azure SQL table inherits attributes from dataset in this graph as well. We can see that a dataset inherits attributes from 2 other types, this asset type and referenceable type. The key aspects here is that an asset type gives the dataset a name, a description, and in Atlas's case, an owner attribute, but in Purview, it's actually a contacts attribute. And then the referenceable gives us this concept of a qualified name. Qualified name is critical in that it is the unique identifier throughout your entire Azure Purview data catalog. So when you do a scan of an Azure SQL table, we'll see that it has something like the server name, the database name, the schema, and then the table name as your qualified name. So something that is guaranteed unique. And that is something critical that you will need to consider as you develop your own custom types as well. So that's dataset. Again, you'll be using this most often. However, another one that is going to be critical for lineage is this process entity type. A process entity type also pulls from asset and referenceable. It has the same exact concepts. However, it has 2 additional attributes, an inputs and an outputs attributes. And a process can take 0 or many inputs of data sets and 0 to many outputs of data sets. And so this is what will give us the ability to create these lineage graphs to associate one table as an input and one or many tables as an output as well. Key thing here again is that you will most likely leverage these as the base types, as the super types that you'll be looking to inherit from. So keep in mind just the core terms of process and data set and their use cases. Data set is like a column or a table. Process is really something that is creating that lineage, the process that is being used to generate an input, or take in an input and generate an output. Last one you'll see on here is infrastructure. It exists. It is predominantly not used in Azure Purview. There are no built-in types that use it, except for one that is inherited from the Apache Atlas world. But for the most part, it's meant to be some sort of hardware or physical infrastructure that you want to represent that its location is on as well. So it's available out there, but it's not heavily used, and I have not seen many customers use it either. Let's dive into an actual example, and I've mentioned Azure SQL Table several times, but we're going to go into a deep dive here. So when you create an Azure SQL Table, you have access to 4 attributes in addition to what you inherit from the data set, right? So data set gave us name, it gave us qualified name, it gave us description, and it gave us the concept of owners or contacts. Azure SQL Table, it has 4 additional attributes: a principal ID, an object type, a create time, and a modified time. Those attributes also have primitive data types attached to them. So a principal ID is going to be an integer, object type a string, etc., etc. So that's what you can query when you have an Azure SQL Table. In addition to that, we are going to have not just attributes, but relationship attributes. And that's what you see pretty much everything to the right is. We have an Azure SQL Table, which of course will have columns. And this columns is a relationship attribute. We'll see a lot more about this later on in the presentation, but a relationship attribute is essentially a pointer to one or many additional assets in your Azure Purview data catalog. So columns, you'll see, is going to be the actual name of the attribute, of the relationship attribute on your SQL table. That columns will point to an array of Azure SQL column types. And this is formally defined, right? You cannot add in an array of Hive columns or an array of Teradata columns. No, they must be specifically Azure SQL columns that are inside of the columns array on your Azure SQL table. Of course, those Azure SQL columns are going to have their own attributes and things that you can record about that column. So data type is a string, length is an int, precision is an int, etc. There's many other attributes on here that you can fill in for your custom implementations or what gets scanned from your Purview scans. You'll note that we have 2 arrows here. We have columns coming from Azure SQL Table, and we have the word table coming from the SQL columns. So each attribute is representing a concept on that particular entity type. So a column has one table that it points to. A table has many columns that it points to. And these are the actual names of the relationship attributes you'll find inside of your built-in Azure Purview types here. Let's go to the top, right? So an Azure SQL Table will also have a DB schema attribute, relationship attribute, and it's going to point to an Azure SQL schema entity out there. And so then the reverse, with that schema has a set of tables that it relates to. So you can follow this graph, and it really is like a graph database almost, and shows the relationships between these entities. A key thing to note here is that some of these attributes, relationship attributes, are required. Some of them are optional. So for example, you can create a SQL table with no columns. But if you create a SQL table, you must create a DB schema that it is attached to. If you're creating a DB schema, well, you're going to be required to create a database, a DB in this case. And then finally, if you're creating a SQL DB, you have to create a server to attach it to as well. And then finally, Azure SQL Server has no other dependencies or required relationship attributes. So if you're going to start spinning up your own custom entities, or you're going to be using these built-in types to create, instantiate entities based on the built-in types. You just need to know, how do I navigate this graph? What is going to be required? What entities do I need to have in existence before I can create them? Another concept just down at the bottom is the important to note, which we'll dig into a little bit later, is this relationship attribute called meanings. It's on every single data set, and it's going to have a pointer to the glossary terms that you want to associate with that table or column or schema or database or server, etc. Every single one will have a meanings relationship attribute, and it points to an array of Atlas glossary terms. So that's how we can create these relationships that are essentially assigning glossary terms to our individual entities. We've looked at a very concrete example. Pulling back a little bit further, and we can look at a more abstract relationship graph of our different types that we can work with. So when we were looking at an Azure SQL table, that's considered an entity, and you might hear me call it an entity or an asset interchangeably, but under the hood in Purview speak, it's from the UI perspective, it's an asset. From the type system, it's an entity. So here we are, Azure SQL table, it has an entity. It has an entity type, meaning Azure SQL table. And then that type has a type definition that we, essentially the contract that was created when you spun up your Azure Purview instance or when you created it yourself through the API. An entity type is going to have individual attributes that we can fill in. Like we saw principal ID, the create time, the modified time, those are attributes on the entity. And those are formally defined in that entity type definition. Following down the entity concept here, we have that relationship attribute. A relationship attribute is a little bit more complex than a normal attribute. A relationship attribute has a relationship type, and it also has an entity type. So a relationship type is actually going to reference another object out there, which has a relationship type definition. And so this relationship type definition is, again, the contract between those entities, between those one or many entities. It's going to say, how do these two things relate? Is one the parent? Is one the child? Can they be created together? Is it an optional relationship, etc.? We'll dive into that a little bit further. But conceptually, it is a relationship is an object that has a type associated with it that points to two or more entities rather. Next, we also have at the very top, we have a process entity. And a process entity also has a type and an entity type definition, but it is has those two attributes of inputs and outputs. And this again creates lineage for us. We'll see much more about this here in some of the following slides. Before we get into the actual pseudocode or the Python code that we'll be looking at, ultimately what Purview boils down into is a bunch of JSON objects that you can manipulate. In an Azure SQL table, we can look at the type definition of this, and we can get very, very specific on what attributes we are capturing, and we can see how some of this is designed and developed here. So things I want you to notice is, first off, again, there's that category where this is an entity category. There are many other many other categories that you could work with, such as a relationship category, an enumeration category, but for the most part, you're most likely going to be using this entity category for your custom types and your custom processes as well. You're going to have a name for a type, so this is an Azure SQL table. You can have a description if you want to give it a much more lengthy description. In addition, something unique to Azure Purview is this service type. You'll see in the Azure Purview UI, if you create a lot of custom types, you can have them all bucketed in one section based on this service type declaration here, right? So in the Azure Purview UI, when you're going to the browse assets, you can say, hey, lump all of these custom types I'm doing under one banner, essentially. And in this case, it'll lump it all under the Azure SQL database banner, which is kind of nice. The options section is really powerful. There, in particular, this one schema elements attribute, it tells us what relationship attribute contains all of the schema that I want to work with. So again, what relationship attribute should I display in the Azure Purview UI? For the most part, all the built-in types have this defined as a columns relationship attribute. But when you're doing something custom, if you have a relationship attribute that you've defined that is completely unique, then you can change it to the schema UI to display based on your custom relationship attribute as well. So it's really just a matter of pointing this option to a relationship attribute you've defined that contains an array of entities that you want to display in the UI here. Going down the list further, we have super types. And again, this is where if you're creating a custom entity, 9 times out of the 10, this is what you'll be filling in. A super type is data set. When you want to work with processes, your super type will be set to a list of just the string value of process. Subtypes, you won't really use subtypes when defining a new entity type, but if you were to query for a given type, you can see what all depends on this particular type by looking at subtypes. Moving to attribute definitions, I've cut a lot of this just to save space, but for the most part, an attribute definition is going to have a concept of, a name. It's going to have whether or not this is required or optional. It's going to have also a type associated with it, right? We saw the principal ID was an integer. The object type might have been a string. The create time and modify time were date time types. So you can get very, very specific here on what is allowed inside of this particular attribute. Again, based on the type, whether or not it's optional or required. You can also specify if it's like an array, you can say how many values are the max or the min inside of that array as well. So this can get very, very powerful as well. Moving to the right-hand side, we have relationship attribute definitions, and these, again, can be defined here inside of your type definition or using this another API endpoint that is, I think, probably much easier to work with. But we'll discuss that later. But here is the relationship attribute definition for the DB schema. In this case, again, how the name of the relationship attribute definition is pointing to what is going to be that reference, right? It's going to be the DB schema attribute name that you'll work with. The type name is pointing to the type of the attribute that you're relating to, right? So it's going to say, I'm only allowing Azure SQL schemas to be inside of my DB schema attribute. This one in particular, again, is optional, is set to false, so that means it's required. And then we have a relationship type name. This relationship type name points us to that object, that type that defines this contract. Again, which one is the parent, which one is the child, can one be created without the other? That's what this relationship type is pointing us to. So you can find out a lot more about that by querying for this particular type and seeing how the two relate to each other. And then again, we have the same thing with columns. You'll notice I also included the cardinality in here. Since this is a beyond just one element, the cardinality is a set, right? So you can have many of these things. Thus, the type name must actually be an array of a given type as well. So how did we get here? How did we get to even just understanding this Azure SQL table type? There's a few ways of getting the type information out of Azure Purview. So the first one is using the typedefs API endpoint. And if we're looking at Apache Atlas, once you've created a client object, you can just call the method getAllTypeDefs, and that will give you something like on the left-hand side, it'll give you everything. All the different type definitions of enumerations, structs, classifications, relationships, entity definitions, and then you can, Control F and look through it. If you know the specific name, you can also get a single type definition, right? With this getTypeDef, the API endpoint is a little more complicated, right? You have to know that it's an entity definition. You have to know the name of it as well. And so once you have those two pieces, you can just get that single type definition as well. Let's say you didn't know what the type definition name was and you didn't want to go searching through all of the type definitions to find it. You can also get an individual entity, and this is just the bulk entities get method, and you get a particular entity based on the GUID that you have out there, and then you can just print out the entity information, and then inside of that entity information you'll see the type name, and then you can repeat the process, right? You can go back and get the individual type def, or you can Control F through all the type defs and see how this thing is defined in here. So just a handy tip for those of you who are exploring a particular entity and saying, how can I extend this? What are the required fields? This is one way of doing this, is again getting the entity based on the GUID, and you can see in the screenshot below, you can find the GUID based on the URL inside the Azure Purview UI. So let's talk about creating a custom type. This is what you're here for. So if you are looking to create a custom type, there are a couple things that you need to do. First off, you will need to create an entity type definition. The Purview Swagger API has the full definition out there, but using Apache Atlas, it's got a quick summary of the most standard common type definitions you're going to do. So that's what the defaults are in there. So ultimately, you need to provide a name and you need to provide a super type. Really, that's the bare minimum that you're working with, right? So I'm going to give this a name of my custom type. I'm going to give it a super type of dataset because I want to inherit the concept of a qualified name, the concept of a description, a regular name, and that owner and contact relationship as well. Next, I'm going to create a custom process type as well, right? Still the same entity type definition contract that I'm working with. And I'm just going to instead super type it as a process, right? So I want to inherit the idea of an input and an output as well. Once I have my base entity type definition, I also need to probably add attributes, right? Because what's the point of creating a custom type if I'm not creating additional attributes that may be required or optional? I can add these different attribute definitions. And an attribute definition, as mentioned before, needs to have a few things like guaranteed the name and the type as well, right? So that's the bare minimum that you need. The default for these things is for it to be a optional field, but you could specify that it's required, right? So in this case, I'm going to take attribute 1, I'm going to make it an integer, and I'm going to make it a required field. So anyone who's working with my custom type, they must provide me with an attribute 1. Otherwise, Azure Purview will fail and it will return an error message if they're going to create that particular type. Once I've created my attribute definitions here, I can then upload those. And in this case, I'm using the post to the types/typedefs endpoint, and that will create brand new types. And that the critical part is that if your type exists, the post will fail. So you will need to then use a put command instead. Same endpoint, but it'll be a put instead. For Apache Atlas, I've instead of using the different methods for those particular calls, there's this force update equals true that will essentially query your existing type definitions and say, hey, does this type exist already? If so, put it in the put method, and then if it does not exist, go ahead and use a post method instead. Now that I've created my custom types, I really need to create an entity as well. I need to actually instantiate this particular entity. So how do we do that? In Apache Atlas, or as well, again, kind of looking at this as like pseudocode, you need to create an Atlas entity. And so in order to do this, you need to provide a handful of required things. So required things really are name, the type as well, right? So I'm going to give this my entity as the name. I'm going to use my custom type because I just created it. And then we also need qualified name. Qualified name, as I've mentioned before, it requires it to be a completely unique name across your Purview instance. And so as a result, you, as you start thinking about creating entities or using built-in entities, need to consider what is the pattern that I'm going to use for my qualified names. For an Azure SQL table, it's going to have something like the server / the database / the schema / the table. For you, again, you can choose it to be whatever you would like, but I would encourage you to follow some pattern and be consistent so that you can, again, in the future, programmatically query for that qualified name based on that pattern. Otherwise, you're going to need to know the GUID for your particular asset, and that becomes, search for it inside of your Purview UI, grab the GUID from the user interface, and then bring it into your API endpoint. And that's a bit cumbersome. So having that pattern and knowing how to build that string of text is going to be incredibly helpful. The GUID that you're going to provide is always going to be a negative number when you're doing an upload. In this case, I have a little GUID tracker, which is essentially a global variable that allows me to get the next negative number each and every single time. The reason why we have to provide a negative number is that it will be translated into an actual GUID once we do the upload, and we'll be able to have a mapping from negative number 1 to A, B, C, D, 1, 2, 3, E, F, G, and that will actually be able to allow us to quickly take our mapping from -1 to that GUID and then start using that entity if we wanted to, or querying that entity immediately after we return a response from our upload down below. For attributes, it's just a JSON object. In this case, for Python, it's a dictionary. And so I'm going to pass in my attribute 1. And again, that was a required one, so I guaranteed I have to put it in. And I'll plug in the number, and then attribute 2, it's a string, so I plugged in the string. An important thing to note for the Azure Purview and Apache Atlas APIs is that if you pass in extra information, it will silently ignore that information. So just be aware of that. There are some things in the Apache Atlas package that lets you validate this as well to guarantee that you're not sending extra information. If you send not enough information, right? If I miss attribute 1, and I don't include it in my upload, it will fail. The entire batch will fail as well. So if I have 100 entities and one of them is missing an attribute that is required, the whole entire batch will fail, and I'll have to go, it'll return a response saying, hey, this particular entity doesn't have this particular attribute, and then you'll have to go fix it. So just some things to be aware of when you're starting to work with optional or required attributes. Just note which one is required and be cautious if you're about to send up extra information that is not going to be recorded inside of Purview. So once we've created this Atlas entity, I'm going to upload it, and that's just a post to the entity/bulk endpoint, and that lets me post hundreds of entities at one particular time if I wanted to. The great thing about this endpoint is that there's no need to create a put method. A post will do an update, and it will do a create at the same time as well. The other cool thing is that you can actually do a partial update as well. So for example, if you just wanted to change, say, the name of this particular entity, right, the display name of it, then when you do creating an Atlas entity, you update the name, and then you can ignore every single attribute except for the required ones, right? So if I wanted to create, change this to my entity 2, I would still need to specify attribute 1, but I can ignore attribute 2 since it's an optional. And if I don't specify the field, it won't make a change to it. But when you have required attributes or required relationship attributes, those must be specified when using this particular endpoint to do an update. Now that I've created the entity, I can get the entity as well, and that's just a get method to the same exact endpoint, and I can specify a GUID in this case, and that's pretty neat. I can specify a list, an array of them as well, which is pretty great, and I can get back a large number of them. This will return both the entity that I'm requesting as well as any reference entities. So for example, thinking of an Azure SQL table, this is going to return the core information, those 4 attributes about my Azure SQL table, but also if I have any columns associated with it, it's going to return back all the column information too, right? Each one of those entities is going to be available in a referred entities section of the response here, which is pretty neat. So one call gets me everything that I need. We've created custom types, we've created a custom process, but we haven't used it. In this section, we're going to start using that custom process. As a refresher, Lineage in Purview is essentially a single process entity pointing between 2 other entities from input to output. And under the hood, this is actually kind of interesting. It's both a relationship attribute and a regular attribute inside of the process entity. But nonetheless, so a process is going to have, again, inputs and outputs, and it also may have its own attributes if you wanted to collect more information about that process, right? Thinking about, let's say, a stored procedure process. Perhaps you wanted to capture who was the author of that stored procedure, and you could programmatically input that information in there. So you might record that on the process. But ultimately, what we're going to see here is connecting inputs and outputs through an individual process entity, and we're going to use our custom process type as well. What you'll see in the Purview user interface is a very beautiful graph of inputs and outputs. And for custom types, At this point, you're going to see question marks and gear icons for these individual graphs, but nonetheless, you can see very quickly that I can take in my sources and I can show my outputs. In this top section, this is going to reference our concept called column mapping, and we'll talk about that in a little bit, but essentially it shows a very nice, easy to use lineage at the column level, right? I can highlight my destination combo 01 column, and I can see through the UI that source 04 and source 03 are both involved in the creation of destination combo 01 in some way. In addition, you can see down in the second screenshot that there is you can create a pretty long graph as well, but eventually it'll start paging, and you can expand this graph one or two at a time as well. And you can get very complex lineage graphs, and it's pretty amazing what you can see, and see the impact of changing something very early on in the chain and where it's going to end up as well. So how do we actually create custom lineage? In this case, we're going to create three entities. One is an input, one is an output, one is a process. You'll see that the process entity looks very much the same as a regular entity, and the only difference is that we're going to have an input and an output. The input and the output, what's happening under the scenes here is that this is actually a header. Instead of the actual full input and output JSON object, Purview actually expects just the GUID, as well as the set of the unique attributes like the qualified name and then the type as well. So those three elements are actually being passed in to the array inside of here as a JSON object. What is important to note though is that the GUID in this case is actually very, very relevant, because when we go to upload those entities, under the hoods, Azure Purview is going to extract, input 01, output 01. It's going to try to create those entities, right? It's going if they don't exist, it'll create. If they do exist, it'll try to do an update. So very important in that you will still need to pass in the required attributes. However, when it goes to create the process, it's going to look at those entities and again translate from that GUID that is being referenced, right? So that -101 and that -100, it's going to essentially have that as a pointer to those uploaded entities, and then those uploaded entities point to potentially the existing or just created GUID inside of there. So that's what's happening under the hood. You don't really need to know all the details there, but for the most part, knowing that you're passing in just like a little header, but if you're going to create brand new lineage with brand new entities, nothing changes here. If you're going to update lineage, right? If you're going to take existing entities and you want to link them together through lineage, you just have to watch out using this method of the bulk entity upload. You may end up potentially changing a required attribute because you'll have to pass in those required attributes. However, the safest possible way is to just pass in the GUIDs if they already exist. So if I already know these inputs and outputs exist, I can then just get the GUIDs and pass in this little GUID object instead, and guaranteed I'm not going to change anything on my inputs and outputs, which is a really nice feature, I would say. The other thing to note here is that when you're about to do an Atlas process update, let's say, or linking together existing entities or changing an existing Atlas process, you need to be cautious around creating or rather overwriting the inputs and outputs. Again, that bulk entity endpoint, that is a create or update, and there's no partial updates for arrays. So if you want to append one more input or append one more output or remove one output or one input, then you need to either download the existing process, take the array of inputs and outputs, and then manipulate them, remove or add the object that you don't or do want. Or we'll see in a little bit here, you can also take advantage of the fact that the inputs and outputs are relationship attributes, and you can potentially delete a relationship instead. So that's a more advanced use case, which we won't go into here, but something that you may end up looking at as well if you start working with inputs and outputs and you need to manipulate them by adding or removing them instead of doing a mass upload. A feature that's unique to Azure Purview is the column mapping in the Lineage user interface. So again, this is an idea that you can create nice column level lineage inside of the UI, and a user can come quickly and say, hey, look, my out01 address, what is that made up of? And I can see it's made up of postal code and address. Oh, great. So I can quickly see that from this user interface, and I don't need to go and explore a bunch of different entities. This is just my one-stop shop here. In order to do this, though, there's a few requirements, especially if you're doing this programmatically. Number one is that you need to have a process entity that is either a built-in or a custom type that has a column mapping string attribute. And so this is not available in the built-in core process type. You have to subtype it, or you have to supertype it, and then add on this attribute definition of column mapping. In addition, the column mapping string that you'll provide is actually a stringified JSON object that has a column mapping and a dataset mapping keys inside of an object. And we'll go into more about what that actually looks like in the next slide. But in addition, you have to have, as part of your dataset mapping, you need to be able to reference the qualified name of your inputs and outputs, right? So the qualified name is what goes into our dataset mapping. And an interesting note is that the columns do not need to exist in the referenced datasets schemas. So in theory, you can create a brand new table or a brand new entity. It has no schema, and you can still take advantage of this column mapping in the Lineage user interface. So let's get down to the brass tacks of it, and this is what you might look like for using Apache Atlas to create your column mapping. So inside of here, you're going to have an array of individual JSON objects. Each object is going to contain two keys. It's going to contain a column mapping key and a dataset mapping key. Dataset mapping, I think, is the easiest. For one object, it shows the relationship between one source and one sink, right? So one input and one output. And that's it. And it must be the qualified name of those individual assets, right? You don't need the type, you just need the qualified name. The column mapping is a little more difficult because it takes in an array of individual JSON objects, which maps the source column to the sink column. And so this is only useful if you are specifying the relationship between those columns. And so that means if you don't have a column with a destination, with a sink, then you probably wouldn't reference it here, right? It actually will not work, right? You cannot have a source without a sink in this case. It just won't display in the UI. So the column mapping, again, takes in this array. You can then pass in as many columns as you have for source and sink for this particular dataset mapping. And the cool part, again, is that each one of these objects that contains column mapping and dataset mapping are independent. So I can actually have something like what we saw where our input 01 has this idea of an address that maps to our out address, and then our input 02 has this idea of a postal code, and that is also made up in our out 01 address, which is kind of neat. So I can, again, create that lineage for the column levels through this concept here. Once I've created this column mapping object, I need to stringify it, right? I need to convert it to a string, and then I'll pass it to my custom process with column mapping, right? You'll have to create your own type for this, or leverage a built-in type like Azure Data Factory types. Then I can pass it in as an attribute. And in this case, right, looking at Python, I just dump it as a string, and then boom, I've got my column mapping UI to be included in the Lineage graph. Now that we've covered Lineage, we can talk a little bit more about an advanced concept of relationships. We've already been using relationships, and we covered it earlier on in this presentation in the sense that an individual entity might have a relationship to one or many other entities. And in this case, right, we've had a Azure SQL table, has relationships to columns. That's what we'll be working through here. We can also have a table that has relationship to a DB schema. We can also then have a process that has relationships to inputs and outputs as well. So what we've been using with the lineage is also really just relationship types all the way down. In Azure Purview, we're going to have a relationship type definition, and it's going to take in a few required fields, such as name. In this case, the name we're working with is an Azure SQL table columns, and that's kind of the sort of pattern that I've seen Purview and Apache Atlas users use, is define, for example, your type, and then what's the parent and what's the child in this type as well. That's usually the pattern I see in names. You can then provide any additional attribute definitions, and this may be anything you want to capture on that relationship between these entities. However, this does not display in the Purview user interface at this time, so this might be only beneficial for your API users. Next, we have a relationship category. Relationship category really defines the behavior of your entities. And so in this case, a composition means the child can't exist without the parent. So if you have a table, an Azure SQL table, and you have columns already associated with it through a relationship attribute, then you cannot delete that table until every single child that is in this relationship, every single column, has been deleted. There's others, such as an association, and I like to think of this more of as like a one-to-one sort of relationship where you have there's no real ties to it, right? I can delete either one, and that's okay, right? There's no real tie to it, and I think of it as a one-to-one sort of relationship. Then there's aggregation, and this is similar to composition in that one is a container for the other, right? So, but it would be that if I deleted the, let's say, table, and I was using an aggregation relationship category, then all of my columns can still exist, right? I can delete that aggregated table and to remove them all, right? So maybe this might be, for example, a dashboard, right? A dashboard might be the aggregated parent of a bunch of reports. And so technically I can delete the dashboard, but all of those reports should still be okay, right? I shouldn't have to delete all of my reports in order to delete my dashboard from a Purview perspective. So that's a relationship category. Required field, very important for understanding what type you're using. 9 times out of 10, you're using composition because you care about that relationship, you care about the parent and child relationship. So I would say stick with that as you can. In the next 2 required fields are end definitions. End-def1, I like to think of as the parent. So in our case, we have an Azure SQL table type as the parent, right? So this type in end-def1 defines what does the parent look like, what is the type of the parent. Then you define the attribute name, the relationship attribute name that will show up on the parent. So Azure SQL table, it has columns, right? Then in composition, we say is container is set to true because we want to say that the SQL table contains, it is the parent, it cannot exist, the columns should not exist without this parent here. So that is in container true. Cardinality is a set because we can have many different columns, and this is legacy attribute is set to false. That's a hangover from the Apache Atlas days and keeping backwards compatible. So that's what you'll see here, and that should be by default set to false. End-def2 is all about the child. Again, we have a type. We say what is the type that is allowed for these children, and that is in our case Azure SQL column. The next we have what is the name of the relationship attribute on those SQL columns, and then we have the is container set to false. This is very important because in a composition you can only have one that is a container. And again, I like to think of end-def1 as the parent, as the container, end-def2 as the child, and so it is not the container. Cardinality is set to single because one column can only have one table, and again, is legacy attribute is set to false. So in this case, now we are uploading a type definition, right? And we have to pass in that this is a relationship definition. So here you go, we're going to pass in an array of our list of our relationship definitions in here. And this is pointing to, again, that same idea of a put or a post to the types/typedefs endpoint. And again, if you are using PyApache Atlas, you can specify the force update to true, and then it will determine whether or not I should do a put or a post. Otherwise, put is for updates, post is only for a brand new instantiation of types. An advanced use case for relationships is to append to an existing array of a relationship attribute. So for example, a SQL table that has columns already in place and I want to add one more column, I can do that. If I have an input array to process, I want to add in one more input, I can do that. That's using this post to this relationship endpoint. I need to specify a relationship object, and in order to do that, that requires just a handful of required attributes, right? So number one is our type name, right? What relationship type am I working with? Any particular attributes, right? The same thing applies here. If I have attributes, if they could be optional, they could be required, so I can specify them here. Then I need to specify my two ends, right? My end one, I like to think of as the parent, but depends on the relationship type definition. There's two ways of specifying your ends. Either number one, you have the GUID, and so I can just pass in a GUID object, right? Where it says the GUID as the key, and then the actual string value of the GUID. And then the other way is here, it's demonstrated in N2, I can pass in this header concept, right? Where I have the type, and then I list out the unique attributes, right? So the qualified name is guaranteed unique, but you have to pass in the type and then the qualified name as well in order to get this to work. So here we go. I can create, in this example, for a given glossary term, right? That's my parent in N1. I can append essentially another entity that's related to it. So I can say, hey, my SQL table, as I need to add on this term of customer master data, and boom, I can use this post to this relationship endpoint to create it. A couple challenges with this endpoint though is that if it already exists, it explodes, right? If there's already something defined there, it will explode if you are already referencing two entities that have a relationship. The important note is that if you are working with, say, an array, right, you have the table as the parent, that you have that GUID, and then you have the child column as the N2 GUID. Since they're not all related to each other, this post will work just fine. If they already have a relationship tied to it, right, you're doing this programmatically and you're trying to rerun it, for example, it's going to throw an exception, or from Purview perspective, the actual API endpoint is going to throw an error. So you just need to be able to handle that error gracefully and determine what kind of error was it as well, based on the error message and the Atlas error message that is returned. That's an advanced use case, but pretty powerful when you're doing things programmatically to be able to just append or update. There's also a delete relationship endpoint that you could be using if you wanted to more gracefully handle, oh shoot, the endpoint's already there, but I need to update it. You'll have to delete and then post to create that changed relationship. One last advanced use case is working with schemas. And so this is all relationships all the way down again. A table might have a columns relationship attribute, and a column might have a table relationship attribute. We can take advantage of that when creating the entities themselves. Using the upload relationship endpoint for the API is handy, is very useful, especially if you already know the GUID or you are just creating it as a one-off, and you already have the entities out there. And you need to make that relationship created. If you're starting from scratch though, right, you're creating the table, you're creating the columns all at once, or you're creating the columns that you want to associate to a given table that exists already, we can do that just in the Atlas entity and the bulk entity API endpoint ourselves. So here's a scenario. I'm going to create a Hive table, and I'm going to create 4 columns to associate with it. And so I give it, a display name, a type, a qualified name, and a GUID that I'm going to reference. And for Hive columns, they require a type field as well, right? So I need to instantiate a type attribute, and I'm going to make them all strings. In this case, I'm going to demonstrate from a table perspective. If I want to add a relationship to it, I need to say for the columns relationship attribute, it's going to pass in an array of, since I'm loading these all at the same time, essentially the header, right, where it will look like the negative number GUID. It's going to say the qualified name, and it's going to say the type that is out there as well, right? So that's the pointer, right? Those three things in combination act as a pointer for the bulk upload that you're about to do, right? And the table and all of the entities being referenced need to be uploaded at the same time to make that work. So that's that table.add relationship, columns, and in Python this is a list comprehension. It just converts, you know, column 1, 2, and 3 into the minimum JSON that we need, right? And that's again type, qualified name, GUID to be able to create this. So that's one way. And so this is again the best possible way you could do this when you're creating everything from scratch, right? The table and the columns from scratch. Let's say though you're just creating one column, and you're creating one column to an existing table entity. So in that case, I could just take, you know, in this example, C4, column number 4, I'm going to add a relationship, and it's going to be the table relationship attribute, and I'm going to pass in the table Atlas entity. And so this is going to be useful if, again, I've created like a dummy table entity, right? It's just got the minimum information that I need. It does have a risk though of, since I have to upload the table and C4 at the same time, it does have the risk that I might change something on my table. So maybe not the best way. You could also set table equal, C4.add relationship table is equal to just the GUID object, right? It's an object with the key GUID, and then the actual GUID that represents the table that exists already. So several ways of doing this for your work, and you just need to know, what do I have available to me? What's my scenario? Am I creating everything at once? Am I adding one more? Does everything exist already and I just need to add the relationship? Do I have access to the GUIDs, or do I want to spend the time and REST API call to get the GUID to fill in there instead? So these are all different ways of working with schemas and relationship attributes very tactically for you to actually start implementing. And this is a great example of how you can get pretty complex with Azure Purview and all these relationship attributes and different ways of building them programmatically. With that, thank you so much for your time. I hope you enjoy learning about the Purview REST API and doing this deep dive with us today. I hope you take advantage of the REST API and build amazing lineage graphs. I hope you build incredible custom types that capture exactly what you need inside of Azure Purview. To learn more, please check out the Microsoft Docs, as well as the official Purview REST API Swagger, and take advantage of the tools that you have available out there in the open source community.